In this video, I'm going to show you how to build a market scanner for Apex Omni exchange. So if you don't know, Apex Omni is a decentralized exchange. And in this video, I'm going to show you how to build a market scanner that will look for certain conditions depending on your strategy and then generate alerts directly to your Telegram account. And even if you're not a programmer, I think you still have something to learn in this video. Towards the end, I will show you how you can just modify a single file using AI to configure any alerts of your choice. So I think it's going to be interesting. You will have something to take away from this video. So let's get started. First, you need to have Node.js installed to follow along. I'll leave a link to this in the description box. You can download the appropriate version depending on your operating system. First, let's initialize a new Node.js project with the command npm init --y. That's it. I'm going to set the type to module because we're going to use ES6 syntax. Then I'm going to install the following dependencies. The first one is .env, which is used to load the environment variables. Then I'm going to install God package to make API calls. Then I'm going to use bottleneck to throttle the API calls. Remember, we are going to use the APIs of Apex Omni Exchange, which will be throttled. So in order to rate limit the APIs, I'm going to use bottleneck package. And then I'm going to use WJS indicators, which allows you to calculate indicators like RSI, simple moving average, and it supports several other indicators. And then we're going to use node schedule to schedule a job. And then we're going to use node telegram bot API to send telegram messages. To install the dependencies, run the command sudo pnpm install. Here, instead of pnpm, you can also use npm. pnpm just allows you to use, efficiently manage your disk space by reusing the packages in the node modules folder. Alright, let's clear this. Then I created two files. The first one is .env, which is where we're going to store the environment variables. And then we have the main entry file, which is index.js. Now let's start implementing the functionality. Alright, the way this is going to work is, depending on the time frame that we want to run the analysis on, first we're going to schedule a job that runs on that particular time frame. So let's say your analysis involves 4-hour candles, then we're going to schedule the job once every 4 hours. And when we run that job, the first thing we're going to do is download all the pairs, all the valid pairs from the exchange. That's going to be the first step. Then we're going to get the candlestick data for the time frame for each and every pair. And once we get the candlestick data, we're going to analyze the data to generate the signals. And finally, once the signals are generated, we're going to send them to Telegram. So that is how the whole thing is going to work. So first, let's implement the schedule job functionality. So I've created a folder called scanner. Inside this folder, I'm going to create a file called controller.js. And I'm also going to create a file called scanner.js. In the controller.js file, first we're going to import the schedule job from node schedule package. Then we're going to import the scanner function that we'll create shortly. Then we're going to create an initialize function that's going to run every 4 hours. So this is where we can specify the schedule. So it's going to run on the 30-second mark after every 4 hours. And the reason we set it to 30 seconds is because we need to let the candle to close. So we're just giving it some buffer time so that when we download the candles are already closed. And then we need to run this on the UTC timestamp, right? And then we're going to run this function that we'll just create and we'll pass the 4-hour interval. All right. And then finally, we just need to export this initialize function from this module. In the scanner.js, let's just create a simple function with a console log statement just to see that it works fine. And then in the control.js file, I'm going to change the schedule to every minute. First, I want to see that it works fine. So I'll just change the schedule to run it every minute on the 30-second mark. And in the index.js file, first let's import the .env package and also the controller that we just created and initialize the controller. That's it. Let's run it. You can see after the 30-second mark that the scanner is running. So after every 30 seconds, the scanner function will run. So that is, we'll change the schedule back to every 4 hours so that we run the scanner every 4 hours. Let's stop the program. Then I'm going to create a file called api.js. Basically, we're going to call Apex Omni API calls throughout the code base. So what I want to do is I want to create a rate limiter and use this module everywhere so that whenever you're making API calls, you will make the API call using this module so that the rate limiting is already enforced. Now, if you look at the API documentation, you can see that the Apex API calls are rate limited at 600 requests every 60 seconds. That is around 10 requests every second. So let's create this module accordingly. So first I'm going to import bottleneck and GOT, bottleneck to throttle and GOT to make API calls. Then I'm going to create a rate limiter. So I'm just setting it to 1 every second. Again, you can push it up to 10 requests every second, but I want to just keep it far below the threshold, so I'll just set it to 1 request every second. And then I'm going to create a function called API proc, which essentially means just API processing, and I'm just going to make the API call and return the response. And then I'm going to wrap this async function using the rate limiter to achieve the throttling. And then we're going to use this api.js file throughout our code base. Then we're going to modify the scanner.js file. So first we're going to get all the valid exchange pairs from the exchange. So we're going to create a async function called getExchangePairs, which is going to retrieve all the valid exchange pairs from the exchange. And then we're going to make the default export to an async function and wrap it in try-catch block. And first we're going to get all the exchange pairs and keep it in this variable. Then we're going to create a new function to get all the candlestick data for a particular pair. And we're going to call this function. We're going to pass interval to the default export, which is what we did in the controller.js. We are passing the default interval, which is 4 hours. And then we're going to get the candlestick data for all the pairs by using awaitPromise.all and store that in pairs kline data variable. Then I'm going to create a new file called findPatterns, which is where we'll include the functionality to identify the pattern that we want to detect and send alerts. So it's going to have we're going to pass 3 variables: the pair name, candlestick data, and the interval. And first let's implement a very simple strategy, which is a coin flip. So math.random returns a value between 0 and 1, and every time the value is greater than 0.9, I just want to generate a signal and pass it as coin flip. And then we're going to return the signals. Again, we will have a more useful or meaningful signals. We'll implement those very shortly, but first I want to demonstrate that it works as expected. And then in the scanner, let's just import this function. And then in the code base, we're going to identify the patterns for all the pairs and the candlestick data. Finally, once we identify the patterns, we need to send the Telegram signals. For that, I'm going to create a telegram.js file, and we're going to use Node Telegram bot API, and this is just standard code you can find on the documentation. We just need the Telegram bot token and the chat ID, which you can generate from Telegram. It's quite easy. You can watch some other video. You need these 2 tokens to be able to send the messages. And we just have the send signals function that is going to take all the signals and send the Telegram message. We just need to initialize that in the index.js file. So let's just import the Telegram module and just initialize it. And finally, in the scanner.js file, we're going to import the Telegram module and pass all the patterns that we find to the Telegram send signals function to send Telegram alerts. That's it. Now we have the market scanner, which is going to run on the 4-hour time frame. So first it's going to download all the pairs, then get all the candlestick data for each and every single pair. Then it's going to find the patterns in the pattern.js file. And finally, when we find any patterns, it's going to send a Telegram signal for all those patterns. Finally, let's run it and see if we are generating any signals. And we scheduled this to run once every 4 hours, but we don't want to wait for the next 4-hour window to run this, right? So I'm going to manually trigger this once we start the program to run it in the first 5 seconds, just to see, that the functionality works as expected. And keep in mind that we just have a coin flip functionality, which gives you a 10% probability for each and every pair to generate an alert. And let's run this and see if we get any alerts. Alright, Apex signals is initialized, and in 5 seconds we should see. Alright, we ran it and we got an error that WAPI is not defined. So we need to import the api.js file, which is where we have the throttled function handler, API handler. In the scanner.js file, let's fix that bug and run it again. Looks like scanner is running fine this time. Let's wait. I added an extra console log statement to know when the scanner is finished running. So let's run it again. This time the scanner is running without any issues. Let's see if we finish the scanner without any bugs and if we get any Telegram alerts. Alright, there is an issue. I'm going to stop the program. We need to pass these two environment variables, right? We haven't done that, so let's do that first. In the .env file, I'm going to pass those two values. Alright, I've created .env file with the Telegram bot token and chat ID. Now these are not real values. I'm just showing it to you how the file looks. But in reality, you need to go to Telegram app and create the bot token and chat ID. On Telegram, you will find botfather bot to create a chat room and also a bot token. So again, you can find it online. It's fairly easy. And once you do that, you should have the bot token and chat ID. Just pass those values here. Okay. I'm going to pass my values and close this file because this is sensitive data, right? I cannot disclose it. So I'll just update these values and go back to running it again. All right. Third time's the charm. Let's run this again. All right. Scanner is finished running. This is the message I got on Telegram. You can see that this is the format we have, new signals and the strategy name, which is just a coin flip, and the pairs that satisfy the signal. So this is how we can generate signals. Now let's implement some strategies and take a look at few real world examples. All right, now let's implement an RSI based pattern detection. So whenever RSI is above 70, I want to detect signals when RSI is above 70 as oversold. So is it overbought or oversold? Yeah, overbought. And when RSI is below 30, I'm going to classify it as oversold. So let's generate those signals. So first I'm going to import RSI package from WJS indicators. Then if you look at the scanner.js file, if you look at the getKlines function, this is how the data is structured. So we have the data, each row inside the getKlines, inside the klines variable is in this format. So we first have the candle open timestamp and then the open, high, low, close, and the volume details. Okay. In the pattern.js file, first let's import the RSI indicator from the WJS indicators, and then I'm going to create a new indicator with the default value of 14. Again, I covered about this library in detail in the real-time indicators video, which I'll leave in the description box. So if you want to understand the library, I suggest you to check out that video. And then I'm going to map through all the candles and create all the required keys. And we already saw that in scanner we have the data formatted in this way, right? So that's what we did. So OpenTS is going to be the 0 value in the array, open, high, low, close, and then we have the RSI indicator, and we're going to pass the closing value for calculating the RSI, and then we're going to take the last bar of these candles, and if the last bar.RSI is greater than 70, then we classify that as RSI overbought, and if it's below 30, we classify this as RSI oversold. That's it. And let's save it. Now along with the coin flip, we're also generating the RSI overbought and oversold signals. So let's save this, and we already have this immediately triggering set timeout in the controller.js. So let's run it again and see if we get any RSI signals. Alright, the scanner is finished running and I stopped the program. This is the message I got on Telegram. Along with coin flip, we now have RSI overbought. So Wi-Fi USDT has RSI over 70 and we found it here. Alright, now let's add a new signal which includes EMA and SMA. So first let's import both EMA and SMA indicators from the library. Then I'm going to create two new indicators. One is EMA21 and then we have SMA200, and we're going to calculate those in the map function. And then finally in the last bar, when EMA21 is greater than SMA200, I'm going to generate this signal called bullish continuation. So let's save it and let's run it again. Alright, the scanner is finished running. Let's stop the program, and this is the message I received on Telegram. So we have these pairs. We have a new signal called bullish continuation, and these are the pairs that meet that signal. So you get the point. You can calculate any indicators of your choice. So WJS indicator supports up to 25 or 30 indicators. So you can use any one of those or a combination of those. And you don't have to just use the last bar. You can combine a group of bars to generate the signal of your choice. You can deploy this code to a cloud server and let it run there indefinitely. And you have Telegram already installed on your phone, and you can monitor the signals so that you don't have to sit in front of a computer all the time and get notified only when the required or the desired condition is met. Now I'm going to show you how to deploy this code to the cloud server. So we're going to deploy this code base using Docker. So what we'll do is we'll first create a Docker image using this code base, and then we'll use docker compose.yaml file to spin up the server. So first I'm going to create a .dockerignore file to ignore the folders that we want to ignore when we create the Docker image, which is just the node modules folder. Then we're going to create this Docker file, which is going to contain the information to create the Docker image. So one thing to keep in mind is it's going to start your app using the npm start command. So you need to have that command in the package.json file. So in the package.json file, I'm going to remove the test command, test script, and create a new script called start, which is just going to run node index.js. That's it. Now we can move this code base to your cloud server and create the Docker image. So let's look at the steps. Alright, so here is my Ubuntu cloud server, which is where I'm going to move the code base and create the Docker image. So I'm going to move all the folders, all the files and folders except the node modules folder and the package npm log file. Okay, and just move all the rest of the files to this Apex Scanner folder in my cloud server. Again, you can deploy this code base to GitHub and import it using the command line interface, but this is quite easy and straightforward, so I'm just showing you this way. You can log into the Ubuntu server and go to the Apex Scanner folder and run the command sudo docker build -t and the image name, which is Apex Scanner, and dot points to the current folder. If you hit enter, just enter the password, and that should create the Docker image. That's it. Docker image is created. Now I already have Portainer running on my cloud server. So Portainer is nothing but a graphical user interface for Docker, which makes it really convenient for you to visualize the images, containers, and all that stuff. So I'm going to go to Portainer and show you this image. Alright, if you go to Portainer and go to images, that's where you'll find this Apex Scanner latest image, which is currently unused. So now what we'll do is we'll just go to stacks, and under stacks we'll create a stack called Apex Signal, which is a stack is the same as a docker compose.yaml file. Alright, so we just create Apex Signals, and here is the YAML file where we're just creating a service called Apex Signals, which is using the Apex Scanner image, and we're just passing the bot ID and chat ID using the environment variables. And you can pass these two environment variables. If you scroll down, you will see an environment variable section where we can configure these two values, and then just hit deploy. To see, these are the two values. I grayed out because obviously I don't want to disclose them. These are sensitive details. So if you hit deploy stack, that's going to create the server. If you go to Apex Signals again, and here you can see that the container is running, and this is going to run every 4 hours. I think we did not remove the set timeout, so it's going to run it right away. If you open that, you can see that the scanner is running because we forgot to remove the set timeout function. But ideally you would just remove that set timeout function, and we'll have a batch job that runs every 4 hours. You know what, let me show you the file. Yeah, in the controller.js file, we need to remove the set timeout, and then we have this schedule job that runs every 4 hours. For now, I'm going to delete this container. I'm going to show you how to make changes to your code base and deploy again. So if you go back to the code base, I just removed the set timeout function. Now you can go back to the file transfer protocol and just move the entire scanner folder. Replace, because the scanner folder has that controller.js file. So we just replace that and go back to the cloud server, create the image again. That's it. We can go back to the stack and deploy, update the stack again. That's it. It's as easy as that. Now if you go to the logs, you see that it's not running, the scanner is not running right away. So it will only run in the next 4-hour window. So that's it. So this is how we can create your own market screener with your own set of indicators. And it doesn't have to be on the 4-hour time frame. If you want to run on the 1-hour time frame, you can change this to 1 hour and also update the schedule accordingly and generate the signal on that particular time frame. Now, for those who are not programmers, all you have to do is change just the single file, which is the pinepatterns.js file. You can upgrade this file using AI to create your desired signal. So I'll create a couple of signals using AI to show you how this works. Alright, so I opened the project using cursor instead of VS Code, and will modify this pattern.js file to create a desired strategy. So I can use command I to open the composer feature in cursor, and you can see it's already referencing the pattern.js file. So I'll just ask it to make a signal for me, right? So let's do it. Cursor is going to modify the file to include this signal, and let's see what it does. Let's hit submit. You can see the beauty of AI, right? So it automatically created SMA 50 and also included that in the calculation. And you can see that here when RSI is below 30, which is oversold, which is what we asked, right? RSI is below. We did not even specify the value. We just said the RSI needs to be oversold. So it automatically considered 30, and the closing price should be below SMA 50, right? It automatically added those two conditions, and you don't even have to know programming, right? It's quite simple. You just have to ask AI what to do, and just once you agree with the changes, just hit accept all, and that's it. You have your desired condition implemented. So let's ask a complicated signal. This was quite easy, right? All it had to do was modify the last bar, right? This is only running on a single bar. Let's ask it to add a new signal which is based on multiple bars. Alright, so what I asked it to do is create a signal where EMA 21 crossed below EMA 50 in the last 5 bars, right? That's a new signal. So let's hit submit. Let's see what it does. Alright, let's review the changes. It added EMA 50, which was not there before, included EMA 50 in the calculations, and it took the last 5 bars using the slice. It took us last 6 values and then performed this analysis. So again, you don't have to understand coding, you just need to modify this single file to include the indicator of your choice and run it on the cloud server. Again, deploying it is really simple. You just have to move this file to the server like I showed earlier, generate the new image, and update the stack. That's it for this video. Let me know in the comment section if you like this tool and if you want me to make more videos on similar topics. As always, I will leave the code on GitHub and it will be available for free to download. Talk to you in the next one. Bye for now.